Okay, great. Thanks, Jeff. Good morning, everybody. My name is Melissa. I'm going to be taking you through our first tutorial. This one has been designed for people who have not used the Rubin Science platform, the RSP, before. So if you've done things like log in and use notebooks or run portal queries, this will be a little basic for you. But if you've just set up your account, this is the place to be. So welcome. Like Jeff just said, welcome to the Rubin Data Academy. The whole session is focused, and like the whole week is focused on beginner level use of the Rubin Science platform. This is the website that has the whole schedule. There's going to be an exit survey. This year, the exit survey is designed to be filled out after every session. We really want some detailed feedback on which sessions were the most useful for you. So you're going to get this link to the exit survey again at the end. It's super short, anonymous. We would love to just hear a little bit about how each session was for you. All right, session number 1, get started with the RSP. We're going to cover some essential concepts today, how to get help, first and foremost, when you run into issues via our Rubin Community Forum. We're going to tell you about the users committee. We're going to cover data rights. We're going to show you how to set up an RSP account, and then we're going to go through each of the aspects and have a bunch of slides that kind of show you all the different things that you can do in the RSP. And then, time permitting, at the end, I'll run through some live demos that you can follow along with your new accounts. All right. So, of course, we're happy to take questions here. I can see hands that go up. I can see the chat, so you can ask questions as we go. I'll try to pause a lot. But of course, once the Data Academy is over, you will still run into issues and have questions. And that's what the Rubin Community Forum is for. You can find it at community.lsst.org. The support category in particular, it is our help desk. Any and all questions about Rubin, the data products, the services, the tools, the survey, anything, they all just go in the support category. Rubin staff monitor this category. We respond to all questions there. It is the place to go. It is the help desk. You do have a users committee that is charged with advocating on your behalf as users of the Rubin Science platform and our data products. They're charged with soliciting your feedback, and they make their reports twice annually to the Rubin Operations Director, and we follow up on all those suggestions. So feel free to reach out to them at any time. Right, Rubin Data Policy. There is a rather large document named RDO-013 that you can access that has the entire policy, but the basics are that Rubin does have a data policy. It does have both proprietary and public data, and data rights holders are the ones who can access the proprietary data. Data rights holders are defined as scientists and students who are working or enrolled at a US or Chilean institute, plus named members of international in-kind contribution teams. Those are the people who have data rights and can access the proprietary data and services like the RSP. And the list of all of the international data rights holders is, oh, that's an old link. We will fix that link. It lives in a new place now, but we'll get that fixed. So for proprietary and public data, the proprietary data, that's the annual data release data products, all the images and catalogs, and the prompt processed images. Over the course of this week, you will come to understand what annual data release and prompt means. All of those data have a proprietary period of 2 years. Access to the Rubin Science platform is also proprietary and for data rights holders only. Then on the public side, that's all of the alert packets, the contents of the prompt catalogs. All other data after 2 years become public, where public means that it can be shared with anyone, anywhere, worldwide. Anyone, anywhere, worldwide can use it, publish data on it, publish papers on it, that kind of thing. And then all of our documentation and support resources, such as the community forum, also completely publicly accessible. Thank you, Tina, for the new link to the in-kind list. All right, so what is the Rubin Science platform, the thing that we're all here to learn about today? Since it will not be possible to download the entire LSST dataset, scientists will need a venue for next to the data analysis. Likers become public as well after 2 years. So Light curves that are from the like prompt processing, the real-time processing that's constantly running through the night, those go out as alert packets. There's a whole other session to cover that. Those are public immediately. Light curves that come out with the annual data release data products, those become public after 2 years. So there's multiple different types of processing that happens, and they have the different aspects of the data policy apply to them. These kinds of questions are really good. Hopefully it all becomes clear over this week. So because the data volume that comes from Rubin is so large, you can't just download it. So the Rubin Science Platform is a set of integrated web-based applications and services running at the Rubin Observatory Data Access Center. It has three aspects, kind of three different ways to interact with the data. The portal aspect that's best for exploratory analysis and visualization of the archive. The notebook aspect that's for like in-depth next to the data analysis, programmatic analysis to the data, the creation of derived properties, that kind of thing. And then there's the API aspect that offers remote access to the Rubin archive, remote and authenticated. So you do need to have a token in order to use third-party tools to access Rubin data remotely. So altogether, the RSP includes tools to query, visualize, subset, and analyze the full LSST data archives, and it's all in a stable software environment. The notebook aspect offers a stable, maintained software environment located next to the data. And in that notebook aspect, it comes with storage space, compute resources, and then, of course, the APIs, the remote access options. All of the documentation for the Rubin Science Platform is at rsp.lsst.io. You should feel free to open all of these links that, in tabs in your browser as I'm talking. You can see user guides. So sign up for an account is the one place that if you haven't yet, you should start here today at rsp.lsst.io. And then there's also user guides. There's a link to our support platform, and then you can always find out what's new. There's also, if you're thinking about doing more serious processing down the road, or if there's features that you thought you would find in the RSP and you haven't found yet, there's also a roadmap up here for services that are still in development. So everything about the Rubin Science Platform can be found in rsp.lsst.io. Let's talk about signing up for a new RSP account. So if you do go to rsp.lsst.io and click on sign up for a new account, that's the same place that this short link will take you, this ls.st/rsp-sign up. You can start now if you haven't had a chance to do this yet. If you don't have an RSP account yet, go to this link. I'll type it into the chat for easy clicking. There you go. So first, the instructions on that page will ask you to understand if you have Rubin data rights. We just covered that. You do need to have an account with either an in-common institution, GitHub, or ORCID. I think Google and Microsoft are also options. The RSP uses third-party identity providers. So you are making a new account, but it's always going to authenticate your access by having you log into that third-party identity provider, and then it's going to send you back. For me, I use the University of Washington. That's where I am. So every time I log into the Rubin Science Platform, which you'll see at the end of the session today, it takes me to UW. I log into my UW identity, and then it sends me back to the Rubin Science Platform. As part of the onboarding procedure, you'll be asked to review the acceptable use policy. Basically, you're using the RSP for science only. Don't misuse the resources. Don't interfere with others. We will find out, and you'll be removed from the system. Observatory system staff have access to all of your activity for that reason. We do need to know if you're trying to mine Bitcoin so that we can not have you do that, for example. And then from there, you're just following the steps at that link. Use your institutional identity and email address. That helps us facilitate the process. And by that, it means it helps us to verify that you have data rights. And we're going to take a moment today and make sure that we get everyone signed up that needs to. So if you've come to this session and maybe you had an RSP account a year or two ago and you don't quite remember how you logged in, go ahead and try right now. Go to data.lsst.cloud right now. If you forgot what identity provider you used, we can look it up for you. If you're encountering other issues, we can also look that up for you. And I think here is where I was going to pause for a moment and let anyone who is having trouble logging in, who had a brand new account that wasn't approved yet, or who needs to know what their identity provider was, can put it in the chat and I'll take a quick look for you. And in the meantime, what's the difference between, yes. So this question that's in the chat, the difference between usdf-rsp.slack blah, 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 and data.lsst.cloud. So there are actually multiple deployments of the Rubin Science platform. The one that is at the USDF is for staff only. It gives us access to unreleased data. It's where all the preparation happens. It's where we prepare tutorials, all the processing happens. So USDF is staff only. Data.lsc.cloud, that's the user Rubin Science platform. So that's the one that all data rights holders can access. Thank you, Tuba. It's a good question. Other questions about data rights, getting access to the RSP, trouble logging in at this point. We do want you to be able to follow along hands-on as much as you can. All right, I'm not hearing many shouts. It's working great. Thank you for the confirmation. I did go through and approved a bunch of new accounts this morning, so glad to hear it. All right, I'm going to keep going with the slides, but if you do have trouble logging in, just pop it in the chat and we will pause and we'll get you set up so that you can carry on with the rest of the academy. Oh, and of course, if you have problems logging in later, the place to go is the Rubin Community Forum, of course. Just tell us you're having issues and we'll get you sorted. Once you do have an account and you've signed up and it's working, we strongly, strongly recommend that you link a second identity provider, especially if you're a student or a postdoc, you're going to be moving institutes in the next couple of years to ensure continued access to your RSP account. If you move institutions, link a second identity provider. GitHub is a great one. Orchid is another great one that you will sort of have forever. And you can follow these instructions to do that. So strongly recommend. If you want to go do that while I'm talking, that would be great. All right, so you've successfully got a new RSP account. What are you getting with that? Right now, you're getting access to Data Preview 1 and Data Preview 0, which we're not talking at all about today, but it is our earlier data release that was simulated. So Data Preview 0 simulated, Data Preview 1 real. You're going to hear all about what's in Data Preview 1 in the next session. So right now, you're getting access to Data Preview 1 via the Portal Notebook and API aspects. When Data Preview 2 comes out over the next months, you will have access to that as well. There is no alternative way to access DP1 or Data Preview 2. An RSP account is necessary. In the notebook aspect, you're getting personal storage space of 40 gigabytes. You have compute resources, 4 CPUs, 32 gigabytes of RAM. There's user-managed groups, so you can share files with your colleagues. There is scratch space that's provided for very large, like intermediate files. So while you're doing processing, there's space to store that gets emptied out on Sundays. And then you get the software environment that's maintained by Rubin staff. All right, a word about remote access tokens. So if you can log into the RSP, use the services, that's great. If you're more of a Topcat user, or if you use other platforms, for example, Noir Labs Astronomy Data Lab platform, which offers like a similar Jupyter Lab environment, and you want to use, for example, PyVO to remote access and grab small amounts of Rubin data, bring them back into whatever platform it is that you're working in, or your third-party client like Topcat, and visualize there. Completely possible. You just need to start by setting up a remote access token. And so here are some of the links that you will need to create that token. There's instructions for setting up that authentication. And then For most of these third party, you will need to know the tap endpoint. So you need to know, like, you need to give it the URL for where you're going to get the data from. So this is here for you. This is also all in rsp.lsst.io, all these instructions. Plus we have some tutorials that we're not going to actually like go through today, the API tutorials, but they are there and we can point them to you if you're more of a TopCat or PyBO person than a RSP person. All right. I'm going to go through a series of slides that just show screenshots from the process of logging into the RSP, interacting with the portal, and interacting with the notebooks. I'm going to go through these like fairly swiftly just to give you a taste of what you can do in the RSP. Then once the slides are done, I'll stop. I will log into the Rubin Science platform and we'll do a few things together after you had a chance to kind of get the overview. So when you do go to the RSP data.lsst.cloud, you will see the little login button at upper right. You can click on that and it will log you in, or you can click on the portal or notebook panel and it will both log you in and take you into that aspect of the RSP. As you're logging in, you're going to select your identity provider from the drop-down menu. You'll be taken to log in with that provider, like I said, and then redirected back to the RSP. One important thing to note is that if you forget who you used as your identity provider, and then you try to log in with something else, it starts you in the process for making a new account because it thinks that's what you're trying to do. This is very common if this happens to you and then you realize you've made two accounts. Don't worry about it. It's a very easy fix. Just let us know in the Rubin community forum and we'll get you sorted out. If you forget which identity provider you used, we can look that up for you. What we can't do is help you regain access to that third-party identity provider. We don't know your passwords for that third party. If you stop having that account, we can't help with that either. So yeah, so make sure you set up that secondary linked account. For the portal aspect, if you were to choose to log into that, there's a user guide. It's at rsp.lsst.io. It gets you started with the basics of the portal. So that is there for you to refer to. There's also tutorials that were specifically designed for using the portal with the data preview 1 data. So you can get started with the tutorial. You could skip the user guide and go straight to these specific tutorials. They start you off right at the basics of how to navigate the user interface and do simple things. And then they build up from there into making like more complicated plots and like viewing multiple images at a time, that kind of thing. So you can find all of the tutorials that use DP1 at dp1.lsst.io. And it's going to be similar for when Data Preview 2 comes out. dp2.lsst.io will have all the tutorials. For Data Release 1, dr1.lsst.io forever. All right, when you first log into the portal aspect, you are on the landing page. It is also, as you will notice in the tabs that are across the top, this is a screenshot that's actually quite old now, back from the DP0 era, but these will have been replaced with DP1 tabs. But you will always start off in the results tab. And since you haven't done any queries yet, it will always be empty. No results will be seen. The portal aspect doesn't require any coding languages, whereas the notebook aspect is all in Python. So if you're not a Python coder, the portal is probably the place where you're more likely to get started. The services that are provided are all the IVOA standards, table access protocol, simple image access, the TAP, and the CS services. You can use the portal to browse data sets, view catalog schema, find, retrieve, and display data, create interactive plots, and we're going to show you some of those things later today. So the TAP service, data is available via the TAP service. And when you, for example, if you came to the portal and you clicked on the I want to interact with catalogs tab, it would take you to another window quite like this, where you'd be choosing which tables you want to work with from the drop-down menus, selecting your table, and then you can interact with the table schema, search for columns that you would want to pull over. You can set constraints on the columns. You can find columns of interest by keywords, such as if you want to see all of the flux columns that are available in a given table to pull those values over. That's the portal is very, very good for browsing the table schema. As you will learn over the course of the week, some tables are very wide. For example, the object table, which contains detections and measurements in the deeply co-added images, that's about 1,200 different columns of measurements that are there. So the portal aspect is really handy for being able to browse through the schema, find the columns that you want. Once you've found the columns that you want and you want to retrieve data, you can select them as columns that you want to retrieve. You can put constraints on those columns, and you can set up, for example, easy comb searches. You're going to learn how to do this over the course of the week. So this is how you would set up a query in the portal using the user interface. There's also, of course, an ADQL interface. That stands for the Astronomy Data Query Language. It's similar to SQL if you're an SQL user. So the same query that you've set up here by clicking on columns that you want and entering your constraints, you can make the exact same query with the ADQL language like this. And there's an interface for copy pasting in ADQL queries, which you will see this week. When the results come back to you in the portal aspect, you have the table of results. You can see here, it's just the columns that we requested. These are, and then all the rows are only the objects in the object catalog that met the constraints that we put on the flux, for example. So you have these objects that come back to you. You have a table that you can interact with. At upper right, there's always a default plot. It's usually just RA and DEC, the first two columns of the table that was retrieved, which you can manipulate using the settings. So you can plot any two columns, you can change to a heat map, you can change the symbols, that kind of thing. And then automatically the objects that you retrieve from your query are shown on the all sky color maps. So this is what makes the portal aspect very useful for browsing, for quick looks at the data. Let's see, does the manual query give you the SQL equivalent version as well? Yeah, a lot of our tutorials, no, that's not the question. Does the manual query give you the SQL? Yes, okay. So when you've set up your query like this, the manual query, you can't see it here, but you'll see it later when I show you in the portal. There's a button down at the bottom that says convert to ADQL. And so you can get this. So if you're just learning ADQL, it's very useful to set up your queries like this, hit the convert to ADQL, and you can see what it looks like and learn ADQL. In the portal aspect, it's not just catalogs, but you can also pull over images and interact with them in the image viewer. For example, this is 6 deep coed images, 1 per filter, UGRIZY, that is displayed. This is also kind of an old image from the Data Preview 0 simulated data, but the interface looks the same for Data Preview 1, and you can do the same kinds of queries. So it's also very good for quick look. If you just want to take a look at a given coordinate, you just want to look at your object really quickly in the deep co-added images. You can do that with the portal. So portal, great for browsing, user interface, no Python. The notebook aspect, on the other hand, is a typical Jupyter lab. You can get started with the basics, of course, in the user guide at rsp.lsst.io. Especially there's a section on using the science pipelines and configuring the notebook aspect. Looks like the purple box is actually on the wrong menu item here. It's configuring the notebook aspect that gets you these options. So how to set up your Git, how to configure the shell environment, how to do user managed groups so that you can share files, that kind of thing. All of those types of instructions are at rsp.lsst.io. Then, of course, there's also notebook tutorials for Data Preview 1. And these are all available within the notebook aspect itself. I'm going to show you how to access tutorials. And these tutorials are all divided into basically 3 levels. The 100 level, as we call it, is all how-to. It's all how to use every service, how to use TAP, how to use SIA, those services that I mentioned before. There's a couple of other data services in the notebook aspect, like the Butler. It teaches you how to use that, how to make cutouts, how to display images, every little how-to about a service or a tool. We've got a tutorial that demonstrates it. At the 200 level, there is one tutorial for every type of catalog, for every type of image. There's other data products like survey property maps, flags, time series features that are derived from light curves, everything that Rubin calculates from the data and releases as a data product. We have a tutorial that describes what it is, how to access it, and how to apply it, basically. Then the 300 level tutorials are all science demos. So they're sort of end-to-end workflow type analyses that use whichever services and data products are best for that particular scientific application. So you can start with any of these. They sort of, build up in skills, but starting at the 300 level with the science topic of your interest, that's fine. You don't have to start at the 100 level. You can kind of start anywhere. I will show you how to use the drop-down menu in the notebook aspect to find these tutorials so that you can get started. The notebook aspect itself offers programmatic access to the data in a Python environment. It's Jupyter Lab. The LSSD science pipelines are already installed. You used to have 35 gigabytes, but now you have 40 plus the temporary scratch space that I mentioned before. You can define user groups to share files. You can install custom packages. For example, pip works great. You can execute Jupyter notebooks. If you're not a notebook person, you can also run Python scripts or use command line access to either your own codes or to the LSST science pipelines. All right, this is basically your space. It's like having a laptop in the cloud right next to the Rubin data. You can set up your file system. You can save things in here. You can set up your Git and just basically get to work. In the notebooks, you can retrieve and plot data. You can display images. Firefly is the image viewer. It's the same image viewer that's used in the portal. It's available in the notebook aspect so that you can have images sort of open side by side as you're doing analysis or interacting with the catalogs. And and it works great. If you've used any other Jupyter Lab environment, it's very similar, just with a lot of Rubin services pre-installed. And if you don't like notebooks, that's fine. You can work from the terminal command line or write scripts and execute them. It's all good. All right. We made it through all the slides. And so now I want to give you a bit of a live demo of RSP access. This is also a great time to ask questions as we go. All right. So follow along with me. We're going to start, well, maybe before I actually dive in, any login issues that I can help with before we get started. I missed, how do you access Firefly? Ah, yes, there are tutorials for that. I will try to open one and show you. Yeah. Okay, I don't hear any help, I can't log in. So I'm going to go ahead. All right, we are at data.lsst.cloud. And instead of logging in first, I'm just going to go straight into the portal aspect, and it's going to take me through my login process. We go, University of Washington is me. And here I am on the portal landing page. So the first thing you can notice is that we are in the results tab. Of course, I haven't run a query yet, so there are no results to show. And this probably looks a bit different. Let me reset my tabs. These are the default tabs that show up across the top. So if I want to query for data preview 1 images, data preview 1 catalogs, the alert viewer, which we will cover in the prompt products tutorial, upload your own tables for cross-match, and a job monitor where you can see the status of queries that you've submitted. The first thing that we're going to do is look at a HIPS map, which is the all sky color maps that Rubin makes from its data. It's actually not one of the default tabs across the top, but this little 3 horizontal menu icon at upper left gives you access to more tools within the portal. And so we're going to choose, maybe this is a bit small. We're going to choose Rubin Hips Search from the sidebar menu. So you're going to come here into the sidebar and click on Rubin Hips Search. Wonderful. Now we have the hips map, color map, search interface. It wants you to put in a coordinates for where it's going to land you in the hips map. And for that, I'm going to go to the data preview 1 documentation. This is at dp1.lsst.io. And I've already navigated to the part of the documentation where I know I can get the field centers. And let's choose to use the extended Chandra Deep Field South. So I'll copy paste the coordinates into the chat. And then also I'm going to copy paste these coordinates into the hip search. Having a field of view is optional. The default is a nice like human relevant field of view size. And the other thing that I do have to choose is which colors of the hips map that I want to view. Rubin makes several options for different color combinations. So this, I mean, if you're coming here to look at a particular object, the colors that you choose might depend on your science, might depend on what color you expect your object to be in the first place. GRI is also always sort of a nice traditional color map to use. So let's make sure we select GRI, or you can pick another one if you'd like from the list. There's also single band all sky. So you can browse the sky in a single band if that's what you want. But today we'll pick GRI. So we've got the coordinates in, we picked our map color, search at the bottom left corner. And it should look very similar to this. So there you go. You've done your first portal query. And from here, you can browse around. And if we zoom out, the first thing you can notice, the fields for data preview 1, which you're going to learn about in the next session, are rather small. So in the future, this will be sort of like, you know, all of the southern sky hips map will be covered. But for now, we just have small areas. But you can use your mouse to just sort of browse and look around. Any questions about the hips viewer? Okay, let's go on and do an image search because one of the questions was how to access Firefly. So let's do that first. Back in the portal, we're going to select the DP1 Images tab and come to our DP1 Images search interface. And so here, typical search interface, you have constraints, options of constraints that you can set on the left. And then on the right, it's the table that you're going to be querying. In this case, because we've come to image search, the table is the image metadata. All of the columns of the image metadata file are pre-selected that you need in order to interact with the images. So we leave all of that as it is, leave those columns pre-selected. But we do want to pick which kind of image that we want to retrieve. So first I make this selection on image, on observation type and source to say, yes, I want to put constraints on the type of observation that I want to pull over. Let's only get a deep coad image. Deep coads and difference images are level 3. So I check the box also for the level 3. So I'm going to go after a deep coad image in the R band, which we'll set in a moment. For image product type, leave it at image. Instrument name, data preview 1 was all made with LSST commissioning camera. That's the only option that you have in that dropdown. The collection, data preview 1 is currently the only released data set. So you have that. And then for data product subtype, just the deep coad. So we set up, give you a moment to set up this in the same way. Observation type and source, level 3, image, ComCam, data preview 1, deep coad. What is level 4? Oh, that's a good question. It's unlabeled. I think it is. So the levels are like the IVOA standard levels for processing level. And then level 4 is like another level of processing that Rubin doesn't do. I think if I remember right, it applies more to spectroscopic data sets. I don't know why the button is even there. Rubin doesn't have anything at level 4 or level 0 for that matter, which I also don't know why the button remains. I don't think you get anything if you try to search that level. It's a good question. All right, so we set the type of image that we want to retrieve. Let's set up our location. So we want an observation that contains the point that is the center of the ECDFS field. So here we're getting a deep coad image that overlaps the center. And since it's deep coads, there is no time component. They are stacked images. If you were searching for individual visit images or difference images, which you're going to learn about over the course of this week, they do have a time associated with them because they were taken at a given time. So you can do queries for those with a time constraint. But let's add a spectroscopic coverage. You could get the overlapping image in all bands, but for today, let's just ask it for the R band image that overlaps these coordinates. That is the deep coad. So once we have these set up, search. All right, it's returned the results of our query. You can see from the table it found one deep coed image that overlaps our coordinates. That's great. You can also see that this is still the HIPS map at upper left because we had come here and queried it before. But if we switch instead to the data product, like the deep coed, which is the deep coed that we actually wanted to retrieve, it gets the actual image for us. So this is actual deep coed image, like one patch of it for the observation like coordinate that we requested. Mine is a yellow dot. It might be a different color for yours that shows up here. And this whole thing is the Firefly interface. So here in the portal, Firefly automatically opens if you've done an image query. All right, so that is an example of retrieving an image, showing it in Firefly. For the catalog, the interface looks very similar. These are drop-down menus up at the top where you can select your catalog. It's the similar kind of spatial query that you set up over on the left, plus selecting your columns and making constraints like I showed you over on the right. We are going to not do this because I want to get you into the notebook aspect in the next 10 minutes and show you how to navigate it. So let's move on from the portal. And in a new tab in our browser, go back to the data.lsst.cloud landing page. We're already logged in. Very nice. And this time we will enter the notebook aspect. As you enter the notebook aspect, it's going to ask you questions about the type of server that you want to start up and work in. Pretty much you are always leaving the image at recommended. In this case, image means the version of the LSST science pipelines that you want to use. All of the tutorials that go with the most recent data release all are designed to work with the recommended image, so leave it at that. And then for server options, large is the default. Large is what you should be using if you're accessing any amount of data. Small is really only if you're logging in to like grab a script or a text file or just take some notes or something like that. If you're doing anything with data, leave it at large. Start your server. It's going to start up for you. Are we all starting at the same time? Oh, no, there it goes. Okay. Sometimes like 20 people starting up their servers at the same time. Oh no, almost 40 people can take a moment. All right. This is what it should look like when you first enter the notebook aspect. You will always have this welcome file open. It always will have the links to the most recent data releases. It also always links you to the community forum in case you're having issues, links you to documentation and tutorials, reminds you of the data policies, and reminds you a little bit how to cite the Rubin Observatory. So all of the sort of basic information will appear here for you every time. So this over sort of on the right is your workspace within the notebook aspect. Over on the left, it is right now in file browser mode. So you can see that it automatically lands you always in /notebooks/tutorials. Now this is in your home directory, but you're in the notebooks tutorials folder. Yours, if you're a new user of the RSP, will probably be quite empty because this is the space where tutorials get saved when you pull them over. And I'll show you how to do that in a moment. So if yours is empty here, that is fine. It probably should be. So we are here. The first and easiest thing to do is just get started with a new tutorial. So up at the top, make this bigger, there's a tutorials tab, which you can click on. And it has, right now we have a lot of different kind of data release types that have tutorials. So some just based on commissioning data or that apply in the commissioning kind of era. We have our old data preview 0 tutorials. Data preview 1, this has the bulk of the tutorials right now because it's our only current data release. There's a couple of early data preview 2 tutorials available if you're already starting to look towards what you're going to do with DP2. For remote access to the MPC, which is where solar system discoveries are going, there's one tutorial for that. And then we also have a couple of prompt products tutorials, just sort of getting started with access to individual alert packets, which you will learn about more in the prompt products tutorial on Thursday. A good place to start, though, Data Preview 1 is the current release, the 100 level of how to use the RSP tools. You'll see our 101 series is all about getting started. If you have never used Jupyter Lab before, or if you're completely new to Jupyter Notebooks, you'll probably want to start with 101.1 and 101.2. Today, we're going to start with 101.3, which is our data services overview. I've said the words TAP and SIA and Butler a couple of times. This particular notebook introduces you to kind of all the different tools and all the different ways to access data from the notebook aspect. For me, I've pulled this one over already, so I have a copy. Generally, I always overwrite, so I'm always getting the newest, most up-to-date version of a tutorial. And what that just did is just save a new copy in the folder over here. So for Data Preview 1, our Data Services Overview tutorial, this sets it up. This left-hand menu bar, which, by the way, if you're not seeing it, on a Mac, it's Command B, lets you hide and show. And I think it is, under View and then Appearance, Show and Hide left sidebar will be under View and Appearance. So if you, for some reason, got rid of your left sidebar and couldn't find it again, go to View and then Appearance to bring it back, because we're going to switch it from file browser, like the little file folder icon, to the menu, and it shows you the table of contents for the notebook that you have loaded. So you can see here, this notebook provides like a bit of an introduction, imports some packages, gives you how to access catalog data and how to access image data. All of our tutorials have kind of a lot of narrative text to tell you about what the code in each cell is doing to help you get familiar with Python or help you understand what the various services and code packages and modules are doing. All these tutorials are great for working through step by step. Today, I'm just going to take this one. I only kind of want to give you the briefest of overviews because you can work through this later. If you want to execute all of the cells in a given tutorial all at once, which works fine for a lot of them, some of them with like really heavy data visualization It doesn't work as well if it's like interactive visualization with bokeh and HoloViews and like these fancy packages. Don't really recommend just running all cells, but this one is light and easy. So I'm just going to execute all the cells in this notebook. And it's going to go through, run the code in every cell, and we can just sort of watch it. Right now, today, I just want to give you a brief overview of what this one does. Oh, and it has open Firefly for us. That's great. So the first thing we do is set up our data services. Tap service gets you access to catalogs. Butler is a Rubin-specific sort of in-house data management system, piece of, we call it middleware, that helps you access the data. You will learn, I think there's a whole tutorial or two on the Butler. The CS service is for simple image access, setting that up. We set up the Firefly. So someone had asked before about how to access Firefly. These are the two codes. This is the code cell that opened the Firefly viewer in the notebook aspect. And what I'm going to do actually is click on this tab and drag it over to the right so that I have a nice side-by-side view here. So I have Firefly open on the right. All right, this tutorial just uses, it's the same center coordinates that we've been using sort of for the rest of these examples. And then it just goes through, it tells you what the tap service is, shows you how to do a tap query, grabs some tap data, makes a plot. So very simple kind of overview of how to access data. And then it's going to do the same thing with the Butler. It's going to show you how to make a query with the Butler. Whereas TAP uses ADQL, this might look familiar from the slides. This is ADQL code. The Butler uses a different way to query. And the Butler, whereas the TAP, you can make sort of arbitrary spatial queries on the sky, whatever kind of shape you want, comb searches of whatever size you want. Everything in the Butler, however, is stored in the same way that images are stored. So when you want to get all of the sources in a certain image, you would use the Butler. When you want to find all of the sources that were detected like in some region of sky that can be kind of any shape, you would use the tap service. This will become clearer over the course of the week. This is just a good notebook to kind of start with. So you're doing sort of the same types of queries, but from different services, and then similar for the image data. The Butler is our recommended interface for searching for images in the notebook aspect and pulling them back. This is just showing you how to do that, how to display that image that you got in the Firefly window. And then it's doing the same thing, but with a different service, the simple image access service, making a query, submitting it, pulling the image back, displaying it again. And then we're doing the same thing again, but with table access protocol and the OBSCORE table. So this first notebook, it's kind of a nice example of the main data access services and how to use them kind of all to do the same thing, just to start getting you familiar with ways to access and visualize data. So that is a nice recommended place to start. And so that is most of the basics for the notebook aspect. There's just two more things that I need to show you in here before we're done with this session and you get a break. One is I'm going to switch back in the left sidebar from my table of contents view back into File Browser, because I want to show you that you can navigate to your home directory. I've been using this area as my primary workspace for years now, so I have lots of stuff. Yours probably looks pretty empty. But you can navigate around your repos, your projects, all of that kind of stuff. You just use it as your laptop in the cloud. When you want terminal access, this blue button at upper left with the plus is how you open a new workspace window. You can open a new notebook. You can open Firefly on its own, the Firefly client by itself. You can open it from here, open a text file, or open a terminal. And that's what I'll click on here. So you have a terminal access to your file storage space as well. So that was over in the left-hand menu, File Browser. This plus button opens up the launcher, and from there you can open up all of the services. All right, that's got you into the portal. That's got you into the notebook. You've accessed tutorials. You know where to get started. And we're 1 minute over and into your break. So here's a reminder, if you can take just like a minute to fill out the exit survey. I'll put this into the chat. And I'll hang out through the break and answer any questions you might have. And the next session is going to start at 9.
Thanks, Melissa. As Melissa said, we are due for a short break and we will start the next session at the top of the hour.
You want to